I would be inconveniencing him yet again. I would request Mr. Shantanu Ghosh to kindly come to the stage for the last panel discussion of this national conference. Accompanying Mr. Shantanu Ghosh, we'll have Professor M.S. Gaur from IIT Jammu, Mr. Divyanshu Verma, and Mr. Rama Ramakrishna. Mr. Ghosh, Mr. Verma, Mr. Ramakrishna, and Professor Gaur.
Cyberspace and security. And cut short the time.
The scheduled time for this panel discussion would be 20 minutes, and the topic for this panel discussion would be cyberspace and security. I would request Mr. Shantanu, sir, please have a seat. I would request Mr. Shantanu Ghosh to kindly begin with the panel discussion. Gentlemen, the dais is yours.
Yeah, can you hear me? Okay. So, good afternoon once again. Honored to sort of initiate the discussion on cybersecurity and the cyberspace. So the whole concept of cyber is getting fudged, because what is cyber? Today, anything which is outside our home, we get into that domain, because you're connecting to the entire world, if not the universe. So, and obviously with that the associated risks are coming, and we need to look at differentiated tools which will help us to safeguard that. If you see today, what is India's risk, and I get to work with a lot of defense organizations without naming, you will realize the threat to us as a country is not the gun-trotting terrorists or the people who are implanting bombs. They can be contained, and there are few. But the biggest risk the country today carries is the number of attacks that we get. We have the privilege of doing one of India's most critical networks, or two of India's most critical networks. One is the GST network. The entire GST network, as you know, is now the lifeline of India from a trade and commerce perspective. That is the biggest revenue earner for Government of India. But unbelievable, every day there are hundreds of attacks every moment. This is the real war. It is not terrorism, this is a war which is happening, right? We also run a very critical network, which is the SBI ATM network. You will see SBI ATMs practically every nook and corner, right from the last border town of India, Mana, near Badrinath, to way down in Vivekananda Rock. You will have the SBI ATMs. It's a huge network, but it's a lifeline for India. If that network can crash, it will be kind of creating a havoc. Now, how do you bring security to that? How do you go beyond the normal tools that you see? How do we write differentiated algorithms? How do we do artificial intelligence to understand the threats? I think that's where it is. So I'll open to Sir here to start the discussions.
Okay. So I think I'm odd man out over here in terms of academic inputs, right? So, so probably I'll raise more questions than anything else. See, in academic institutions, when we look at, we have two perspectives. Whether we are working with the computer center or any, so the shape is changing, which I'm going to talk at the end also. Till now, we used to be, we thought about computer center as a bunch of computers, you know, 100, 200, 300, and then a cluster of data center, or data center's new word, then HPC setup, and improvised, incrementally growing network of different kinds, which is, you know, potpourri of different technologies, which has grown in time. And since education institutions are not for profit, so we have to live with the network minimum 10 years. Corporate says 5 years, but we live 10 or more years. Last network which I designed, typically 12 kilometers optical fiber and 8 rings, and using extreme technology. I don't know, the company still exists, I think. Still, yeah, it does. Yeah, Extreme is there because they are 2-3 companies. In fact, one of them used to be Kalpana, which was actually bought out for somebody else, but again, good technology. So coming back to the point, so we have to live with it, because our motivation and the cost cycle is not commercial. It's not driven by cost. We have to live till it lives as network. Usually companies say it's a lifetime warranty, and when you probe it, that what is meaning of lifetime, they say end of shelf life, or for them it's 5 years. They don't expect any service call beyond that. But as I said, that we are not for profit, but still we are expected the services with lot of quality assurances. Somebody said that 2 a.m. call will come and you have to run it, and those solutions may not be exactly available, and there is no company which will give you actually immediate answer even while you are in service contract period. But at the same time, for some companies, if you are working some center of expertise or center of excellence, it becomes a lab of network, provided the companies actually share their APIs. They share some kind of code on which our students can work. So and it does not happen very often, actually, let me tell you, actually, because I have tried with multiple companies to get the APIs, typically in SD and other stuff. We had a limited access to that to actually start working, because they sit quite on their proprietary code. Very few companies open up that this is our stock and you can work on it, try it. Slowly, as I understand, they are opening up with defined APIs where the apps can be developed. Probably it will give us better access. But till now, there's a huge limitation. Networking is a black box where you can connect, you can run the network, but you cannot do much programming. Any programming will come with some kind of licenses which you have to pay, and at times we don't have money to pay, actually, right? So as I said, it's academic perspective. And the second point, when we are doing the research for that, research in networks or security, which I've been involved with for some time, it has got a limited applicability. When somebody talked about malware and different kind of ransomware, Checkpoint I was talking about, the state of the art, nobody shares data. So you have to go for malware creation of synthetic type, which academic community and journalists probably believe us that this is the kind of metamorphic, polymorphic and different kind of malware strains which exist. We do information leakage analysis, kind of, but at the same time we have a limitation that how do you match with the actual expectation of the product. Even the POC does not happen in security because we don't have access to data, and the agencies are very, very quiet on that, at least in India, to share the real data. So we have to work with synthetic. So we never come to know what is the efficacy of my technique, my method with this. So we live in a limited knowledge domain. Only advantage or only experience we get at times when dealing with the networks is is this some kind of alarm, is it? No, everybody says there's firewalls, right? Most of the people have worked, because IP tables and EB tables, they are available, and we actually wrote the rules because we could not buy a latest possibly edge router. So we put 2 Ethernet cards, wrote some rules, and then packet filtering started. But it's a very good learning experience. But at the same time, it worked because they're not huge and complex attacks as GST or ATM network might be looking at. We are soft targets, but nobody want to attack that often. It happens, but not that often. So I would say rather than the technology, we are lucky actually not to get affected by that. So these are few thoughts possibly from the institution side I'll add while looking at the security, because security per se for institution is very expensive proposition. If you go for Palo Alto or Checkpoint for complete suite, it will be very expensive, and the licenses will come with number, with the service attached with it, and usually we have the compliance of say 4,000 protocols. Possibly we'll be using 40 out of 4,000. If you look at the data sheet, it's a huge one, right? So, so these are the questions which need to companies or the corporates need to work with us to tell us that these are useful and these may not be useful, and hence if some kind of customization can happen for the product life cycle, so we become more abreast, right? So thank you.
So thank you, Professor, on this. On a note on licenses, especially security licenses, I think many of the software companies, many of the normal IT companies do have a special program for university campuses. which we call the special campus license, etc., which are so we definitely look at universities and students in a very little different way, not in a commercial way, being non-profit organizations. So most of us would have that. So happy to sort of collaborate on any of those areas, and I think most of the companies do. So let me go over to Mr. Ramakrishnan, Dell Director. Rama, how do you see the security unfolding, right? And what are the, as you interact with the market, where are the main concerns coming beyond the normal security setup that we have both in the data center and outside of the data center? What are the new issues and threats that you see, and how are you looking at countering them?
Okay, so let me talk from product development point of view, right? So security, it's a catch-22 situation, right? You know, today we implement something, we, you know, take care of all precautions, but tomorrow something else will come, how to break it, right? So one, you know, you have the enterprise network setup, you have firewalls, you have, you know, perimeter control, but at the same time, what we look at from R&D point of view, how my product is designed, developed and implemented, what kind of security engineering that we are implementing it. For example, if, you know, while implementing a product, you know, if, you know, we are not really taking care of our memory allocation, we are leaving something which, you know, any hacker can inject remotely and then take control of it, right? So threat modeling, you know, at the time of product engineering, we keep that in place. And now design for security. Earlier this was not the you know, concept at all. We always try to meet functional requirements. We never used to focus on the security engineering as part of functional requirements. Now the product is not only developed, is being validated, qualified from the security point of view. So design for validation, design for security is part and parcel of any product development, right? And now there are technologies around it, right? So we you know, have a process called STRIDE, right? Where we talk about threat modeling, we talk about penetration testing, we talk about remote code injection, basically to look at how the product is stable, reliable from the coding, implementation and validation point of view. So that's at the software level. But security is further going into at the hardware level also, root of trust. You know, for example, if I am upgrading NIC firmware or a BIOS in a server, you know, if somebody gets control, will I allow, or what kind of test I am doing? So at the root of trust, I will look at how this particular entity is reliable, is authorized or not, right? That's very difficult to crack it, right? Because the comparison happens at the hardware level, at the processor level, right? So these are all the technologies that are being developed as part of product development for every enterprise class product. And for example, mission critical, you know, earlier we used to have completely proprietary. You know, Devanshu talked about Stuxnet. You know, Stuxnet, even though PLC is proprietary, but somebody took that USB key, inserted, and that took control of it. Control of it in the sense it fed wrong data. Even though the RPM of centrifuge was going in the right direction, but it fed wrong values, and the entire process got shut down. That took Iran nuclear research almost 10 years back. But that was completely industrial system and completely proprietary, completely safe. But there are avenues to do that, to play with it. So earlier, entire industrial controls, even for example telecom, used to be completely proprietary, in the sense the product with the silicon is proprietary, the board is proprietary, the design is proprietary, the operating system which goes in is proprietary, and the application was proprietary for a particular function. So it was very difficult to crack. But now, you know, time to market, that is no longer valid. You know, time to market is very important, and open standards, open technology has come out. So even industrial systems, for example, when I worked 25 years ago, all distributed control systems were proprietary. Today, they are all based on, you know, open standards, open technologies. You know, internet has made it much more open. So now it is much more vulnerable, but at the same time, they are extremely important, and they will, you know, open up new challenges, new opportunities as well. So not necessarily security every time it's only the denial of service. It could be loss to human also. For example, if power plant is, you know, not managed properly, you know, it could create a big explosion. So industrial systems, earlier we used to think, you know, very safe, no longer, but doesn't mean that there are no precautions and there are no safety network around it. So firewalls and network precaution is external, but at the same time, while developing these products from the silicon level, from the operating system level, from the firmware level, there is a root of trust every level, and that's where the products are being developed.
Yeah, thanks, Rama. I think that's a very good insight. And you talked about the industries, right, which many of us miss. We'll only look at the IT system. They're very, very critical. If the power plant shuts down, if the steel plant shuts down, it's a great, great loss to the national economy. But more importantly, there could be havoc, or there could be calamity for people who are working there. Recently, something happened in Bhilai steel plant, if you recall.
Right.
And you were also right. In the earlier days, it's not that the security risk was not there. It was always there, but it was contained because everything was proprietary and it was so difficult to crack.
Right.
For instance, I started my career in a company called DEC, Digital Equipment, where practically every shop floor we used to work with the PLC and DCS systems. But it was completely secure because of those machines. Nobody knew the operating system, what is inside the operating systems, VAX, VMS, and the network was on DECnet, right? So nobody understands the networking protocol. It was so proprietary. So it was very difficult to hack. But now with open source, with all the good things that the open source is bringing, and it also is bringing the risks. So I think that's the, and you're also right, it has to go to the product engineering level. Security has to be thought at the engineering level. With that refrain, I will go on to Devanshu from Intel. I know Intel is doing a lot of research at the processor level to see how to look at security in a very different way. So if you could throw more light on the initiatives that Intel is taking to securitize the very basics at the chipset level.
So very valid question. I'm audible, right? So now two things. I'll reflect some of the thoughts shared by Professor. That security is now inbuilt. So it has to be inbuilt in the curriculum, as I call it. It has to be inbuilt in the thought. When student enters a college premise or university premise, he or she has to understand there is a security involved in the attendance system, in the app system, in the marksheet distribution system, wherever it is. This will bring up a lot of solutions that can be developed in-house, and probably if Nicira came out of Stanford, something can definitely come out from BHU, which can throw a different perspective to the entire industry to take a detour and think security in a different way. I can tell you a couple of good examples on, you asked on the chipset side. At each level of security is being addressed. Say there is a process called SDL, Security Development Life Cycle. Today, any corporate you take, the product shipment can be stopped, including my group, if we are not security qualified. Now the question is, how can be my security better than your security, right? There is no question like that. Everybody says it is secured. So end result of this comes from customer. If the customer is aware, and security, I know that it is not one size fits all, the customer can call the shots. University can call the shots and say, if I have a web exposure which is 20% higher because my focus has been web and distance education, so on and so forth, my security will be different than a security which is for an engineering group which is in like a biochemical lab, where excess security is much more important than a web security. So security, it's not one paradigm, as I want to say that. It's a different paradigm, and as a user, we have to be more careful when I choose a product. We have to be very clear that what I want in the security. Say Intel processors are very general processors, right? x86 96% market share, so on and so forth. But you know about Spectre and Meltdown, if you are aware of. Spectre and Meltdown were two vulnerabilities, which was just not Intel, which was every processor in the world has it. It came out as Intel, it's not true. So what I'm saying is the same thing which I repeated was, the systems and the chips and the instruction set which were designed probably 20 years ago were designed with good intention, noble causes. Right now there are gaps. I know that the data in the cache stays for a transient time, and the data is clear text. All I need is to figure it out. Just to add, I come from Wi-Fi domain, I told you. There's a very standard protocol called WPA2, and I know each of you configure that. WPA2 had an inherent vulnerability which was discovered 4 months back. We worked with a Norwegian university, which two researchers figured it out and gave us that, okay, this is what is happening. We quickly fixed the fix. But inside the industry, the focus is more on creating the product. So the amount of testing that a university or a user can do and slap on our face, that can never be done inside a product engineering. So we keep it that, okay, Intel has a lot of inbuilt insecurity, some I can talk, some I cannot talk. But at the same time, Intel security is also governed from the market. We can qualify the product to a level saying that, okay, there are now new, like one of the things I want to tell, in the era of hypervisors, Intel has put a lot of security in the chips that can give hypervisor security, the root permission, and OS not the root permission. However, this is very early, and this is tested by probably 20,000 employees in Intel. When it hits the market, it will, I'll say, rubber will meet the road, and then you will know that what is the strength of this solution. Because at a point of time, can create a very flashy PowerPoint and show it out, it's a wonderful best security in the world, but when it meets there, you understand, okay, now it doesn't cut the corner because as a user, as an organization, as a like institution, you test with 2 lakhs users. No company has the manpower to test it. And what I want is, you slap us back, saying this was bullshit. I don't care about you. Because, but what is needed is, you have to be aware what you need from that. So that's my perspective. Yeah, sure.
You mentioned, something, it has to be defined by security. He also mentioned that designed for security, and you will define security for which you can match. Now, security, as we understand, is a very functional thing. It's very difficult to abstract it. So how do you design for that security? So we can say security against some known vulnerabilities, but I cannot define for 0 day at any point of time. So how do you assess that it's a good secure solution, or it's not a good secure solution? Both of you actually, because he talked about design for security, and you mentioned that.
Yeah, so it cannot be 100% 0-day security. It's evolving. You analyze the current vulnerabilities, and then how you are, taking care of them. That is one. That is straightforward and simple. Second, at the time of your product development, how reliable your functionality, in the sense that I gave an example of memory allocation, right? How reliable is your memory allocation if you are dealing with buffer management, for example, right? And second, what kind of authentication authorization mechanisms that you are using internally from one component to the other, right? So if you are not leaving any holes, then you are making any hacker very difficult, right? At the same time, but hacker is also working on those, right? So for example, this Intel meltdown, somebody really analyzed the Intel x86 architecture, then he looked at the cache. Yeah. Point taken. It's a processor meltdown, not just only Intel. Yeah. But got exposed. So these kind of things will happen. Somebody carefully analyzing what's actually is implemented, then obviously they come out with new. But when you are developing a product, make sure you are not leaving any holes in that. Right? That's part of our security engineering. But earlier, limited, right? Right, absolutely. So earlier, the development model or the mindset was, if I meet functional requirements, was good. If I meet my performance requirements, was good. Is it reliable? Is it sustainable? Was good. But now we are also looking at how good is that in terms of leaving any holes in the system.
So just to add to what Rama told, the other thing which is very important is to look at the standards which were designed 20 years back. I can tell you, at least I have fixed at least 15 to 16 vulnerabilities in OpenSSL. When I was a developer in Broadcom and I was using the domain, we audited it, and I thought, man, there are like 20 holes I can see buffer overflow can happen immediately. Because OpenSSL was designed long back, and nobody looked into it that, okay, what is the security perspective inside that? They look, okay, if you can log into a remote machine, my job is done. That's not the case right now. We understand that computers are prevalent in the hand of good people and bad people. Earlier computers were with labs. Earlier computers with government organizations. Earlier computers with very few people. Now it is with the good people and bad people. And the second is patch management and maintenance. If you have a system, the way we oil our car's engine, the way I take vitamin capsule, and I do take it, we have to be thinking about our digital systems also. How is it used? If there is a download that is beyond my expectance, I get worried, right? Okay, why is this download happening? And at the same time, every digital institution needs to have a security officer who can think from that perspective, that if there is an attack, the second step is red teaming. You have 4 or 5 developers or 2 QA people who use Kali Linux or Burp Suite. These are tools world over, all used everywhere. NSA, CIA, everybody uses that. And you can develop your own tools. Nobody stops you from that. Who test your DDoS capability. That, okay, what is my limit? If I am hit with 10 exabyte of DDoS attack, I'll break down. But I know that, okay, I don't need somebody to allow me this many requests coming to my website. So security has to be designed from day zero. Now there is no foolproof security. It's a cat and mouse game, I totally agree. But that is the civilization, that's why a police and an army or anybody exists. So that's my answer, Professor.
Over to you for final summary. It'll be wonderful to hear a summary from you before we end the session.
So, as I think the last word he says, cat and mouse. So, we don't need police or army if we don't have any crimes, right, or any kind of militancy. But we will have it because that is also now one more industry. There was a mention of that what we look at the websites or open content. It's a very small portion. Then we have the deep web and the dark web. And there are people who are making money out of it actually, and there is a clear mandate for that to let them earn. And the interesting part is there is no legal boundaries for that. Somebody is sitting somewhere and doing somewhere with no geographical boundaries defining it. So you have whole of the world as a wherever internet is connected is your playing field. Second thing, like he mentioned SSL, which is very interesting. Typically in networking concept, internet was never designed for commerce. It was designed for academic file transfers between the universities. Somehow somebody caught up with it and it worked, and rest is the history. So we talk about DOS, DDoS. IPv4 is not designed to trace back. Cannot go and catch the real culprit. Virtualization on one side allows you to use the and commoditize computing, but at the same time it allows to fake your IPs and Ethernet, MAC addresses as well. So we do something, but every technology has got dual purpose. So, and hence the security is being earned, functionality is earned at the cost of security. And security is a control. People don't like controls. Looking at the functionality. So we have to evolve, but as we have to learn to control ourselves, we have to learn the security, that how the functionality can be improved along with the security. So I think that's my passing words.
So wonderful, sir. Thank you very much, and I hope you enjoyed the conversation. Thank you. So over to